אוקיי, שלום. אני אציג את עצמי בעברית, נעבור לאנגלית אחר כך. אני דור, מאחד המייסדים ב-ScyllaDB, זו חברת סטארט-אפ שיושבת לא רחוק מפה, ואנחנו מייצרים דאטאבייס חדש, נקרא Scylla, והוא תואם לחלוטין עם Apache, עם ביצועים הרבה יותר. So the presentation is about 1 million operations per second per node. So if you pour Azure presented with Office 365, 200,000 operation with what was it, 30 nodes, and at the Cassandra Summit 2 months ago, someone presented 1 million operation using 60 nodes. A year ago, they used 300 nodes. We do it with one node. Actually, relying, we managed to do much better. So we're doing 1.8 million with a single node, and it's get better even. So practically, what's Scylla? Scylla is a re-implementation from scratch of the Cassandra design and scheme. It's fully compatible. The server side was implemented from scratch using C++, while all of the other tools like clients, tool, administration tools, DevOps continue to work, and there is no modification there. We do not have clients of our own. So you continue to work with your own drivers, etc., etc. Basically, in one sentence, we give you the power of Cassandra with the speed of Redis. We're actually faster than Redis, but in a sentence, I believe you got it. So a bit about throughput. You can see all of the benchmarks on our website. We tried to be as fair as possible. Most of the time with the benchmark was to tune Cassandra to see that there's sense in the performance that it provides. I'll go a bit over it through the presentation. So if you go to ScyllaDB.com, there are presentations there with detailed environment about the setup, about the configuration both of Scylla and Cassandra, and you'll be able to get all of the details. We're pretty much driven by engineers within the company. So if when we were here, then we weren't exactly 10x over all of these columns. Then my engineers told me, you're lying, we're not 10x, we're 8x here and 5x there. I told them, let's keep it simple. With 10x, when we'll be better than 10x, I won't change and say now we're 11x. And you'll see that it's getting better. This is the former performance we got with 1.2, 1.3 million, and now it's 1.8 per node. And it's get better with cluster. So that's the Cassandra 2.1 version versus Scylla. And this is write-only workloads, just 100% writes, 100% reads, and mixed workload of 50% reads and 50% writes. To be accurate, it's Gaussian distributed, more to represent a real-life scenario. So the reads, all of the writes, of course, go to the disk, and some of the reads are served from the cache, some go to the disk. Latency-wise, sometimes it's more important than throughput. Then things are really good here. Lower is better, so Scylla is the blue line, and Cassandra is the red line. That's milliseconds. So we're good on all of the parameters. It's even becomes better on maximum latency. The real results are even better because there is something called a coordinated omission, and it was tested using the Cassandra stress tool, which isn't good if you follow the Azul JVM logs, then you'll discover that it doesn't measure things well, and if you do measure things well, the difference will grow. Another really interesting and important factor is that on this setup, it wasn't fair because we performed 250,000 ops while Cassandra performed lower than 150. So a fair setup would be to send the exact amount of ops for the two databases, and the latency gap is expected to grow. In general, basically we work on virtualization technology and operating system before. For us it was like a joke where a database can perform several thousands operations per second or tens of thousands. Today's machines are equipped with gigahertz frequency, with tons of cores, tons of memory, and the tendency is just to grow it. So it doesn't make sense to settle with really low performances, normal databases that are there perform pretty bad. So that was the opportunity, and that's what was why the reason that we implemented that from scratch. And we wanted, of course, we wanted to utilize the user base that Cassandra do have. And now, when I speak about compatibility, then there are a lot of good things in Cassandra, not just bad things, especially in terms of high availability, fault tolerance, very, very flexible replication model, etc., etc. As you know, CQL. So we adopted the good from the Cassandra world and matched it with really, really good performance. That's our clustering benchmark. I added it here because it's more of the same, but sometimes when we talk about single node performance, someone may assume that we do not have a cluster. So we do have a cluster. The gaps with the cluster even grow larger because Cassandra doesn't scale fantastically linearly out of the single node. So the gap here grow, and we perform around between 1.5 million to 2 million for a 3 node setup. It's the nodes are physical nodes and are regular servers that DataStax recommend. It's 2-socket, 12-core machines with 64 or 128 gigabytes of RAM and SSD. So what's compatible? Basically, we strive that everything will be compatible, and it's supposed to be an actual drop-in replacement. On a website, we joke around and we say that we have the magic script to boost Cassandra, and the script is 3-liner, is to shut down the Cassandra server, boot up, install the Scylla RPMs, and boot up the Scylla server, and that's it. And practically, this is it, because if this is a Cassandra cluster and that's the Scylla cluster, you access it through CQL. We use the same grammar that Cassandra used, so it's totally compatible. The SS table format remains the same, so the same file, and you can actually boot on Cassandra files, SS table files, and Scylla will use it. Actually, if you wanted to go back for any weird reason whatsoever, then you still have the possibility to go back because the format remains the same. In the future, we'll develop our own format in addition, but we'll always keep compatibility. I'm sorry?
Which version of Cassandra?
Good questions. It's 2.1.x.
So it's Thrift or just
3 is out there, it's true, and it's
do you support Thrift or just
So Thrift is a good question. We support CQL. We have a half-baked implementation of Thrift, which we started with. We pause it, and we hope that we know that Thrift is obsolete in general, although most users still have it. So it's obsolete by DataStax obsoleted it in their newer versions. They want everybody to move to CQL, and CQL is indeed better. But of course, there are plenty of there are reasons, specific reasons where Thrift may be better. but it will vanish in time. And we decided, initially we took a decision to pause Thrift, but now, because when we talk with customers, there is a demand for Thrift, and the users do want to have one version of the database, whether it's Cassandra or Scylla. So we're adding the complete support for Thrift. It will be ready around January, February timeframe. So it's in 2-3 months time. And the way you manage the Scylla is, again, the same. We support Node2. The implementation is in C++, but we didn't go and rewrite JMX protocol for nothing. So we added a JMX proxy process that runs alongside Scylla and translates JMX commands into our REST APIs. So basically, as a user, you keep on using the same tools. The Node tools, or even DevOps should work when you approach Scylla. Even the YAML file remains, and everything else. And the way you snapshot the database and restore everything, you do not have to change a bit. And that's the design decision that we took, especially to make the journey simpler to move the database. As an anecdote, I asked one of the engineers to take a job of enabling Spark over Scylla. The guy came back the same day, says, job ended, it works. He used the latest and greatest Spark connector, and that uses CQL, and it just worked. So that was that shows you pretty good sense about compatibility.
Cluster per cluster, not via single node.
Yeah, it's a really good topic. So it's all compatible, but you cannot mix and match a Cassandra cluster and a Scylla cluster, or multiple data centers within the same cluster. We didn't do that, and we do not recommend to do it. The reason is, there are multiple reasons. One of them is that we wanted to have some flexibility with our implementation. We do need to perform better, and that's part of the things that help us to perform better with a cluster implementation. The second thing is that there are so many Cassandra versions out there, it will be a nightmare to validate and QA that, and if you have a problem, it will be almost impossible to figure out what was the problem. And the last thing is that it's not that if you'd like to bring up a new data center within your cluster and say that's the new data center, that's a new code, and I'll bring on this new data center and slowly move things, and then I'll throw the older one. Practically, in terms of clustering, it's all one big ring, it's still one cluster, and all of the nodes gossip between themselves. So it's not that safe. It's not. It's just logically separated. In practice, it's not. It's the same physical ring or so. So it's a dangerous move. So we do support like migration between Cassandra to Scylla by doing offline, just shut down and boot. But it's then you need to incur some downtime. The other possibility that we develop right now is to add a proxy, a transparent proxy that will basically reside on all of the Cassandra nodes and transparently send CQL operations to the separate cluster that runs Scylla. And using this transparently will replicate your cluster elsewhere, and you'll always have the possibility to check and validate the newer cluster. And only when the user feel comfortable with the new cluster and knows that all of the data was migrated, then you can shut down. You can do it for a month, even just to be on the safe side. So what would you do with 1 million ops? So there are companies who do need 1 million ops, like Apple uses Cassandra extensively, Comcast, and many other large players. But the average player may not necessarily need 1 million. You would need fantastic latency, and especially the 95 percentiles and 99 percentile, that's pretty important. But what can you do with the performance? So if you do not need 1 million, but still you need a lot of hops, then you can use Scylla and just shrink down your cluster by a factor of 10. It doesn't just help to reduce the cost, it also helps to reduce management operation. If you consider MTBF, mean time between failures, then there are physical rules where the hardware need to fail or may fail every 3 years. If you're running a large cluster, then the tendency of failure is just larger. So the smaller your cluster is, the less failures you're going to have, and it's easier to manage. It can handle any traffic spike because you have tons of spares. So that's trivial. I find one of the most important properties that Scylla enables you is to have better data modeling or more sophistication in the way you model your data. Because due to performance issues or some other quirky issues that lies within Cassandra, some people choose not to use the sophisticated feature of Cassandra, and it's far more sophisticated than a regular key value store. I can say that for Cassandra. There are lots of good things like lists, maps, indexes, especially with the next materialized views, and plenty of other things. But many choose just to use it as a key value and use blobs to store their data and put the burden all on the application, or the application developer many times. So it slows the developer down, and that's the problem. Using the maps and the indexes, each of them has costs between 10% to 30% when you use Cassandra. When you use Scylla, then you still you have the cost of using more sophisticated features. But since the performance is 10 times better, then practically you won't see these in action, and you'll have safer in terms of typed columns and typed cells, safer development, and also faster.
Speaking of the sophisticated features, do you have your own implementation of Paxos, for example?
And Paxos, Paxos is lightweight transactions.
Yes.
So
You have your own implementation?
there are a few things that we haven't done yet, and we will close the gap. It's about counters, secondary indexes, user defined functions, and lightweight transactions.
I mean, the reason why people don't use these features in Cassandra because they don't actually work. It's proven.
Some of the problems lies there, and especially because of that, we chose other features to implement first and only to close the gap later. For example, the counter implementation is improving in time. It's not necessarily the best piece of engineering, but things improve in time. Like instead of secondary indexes, you're going to have materialized views. So things improve. With Paxos, the main thing I've heard so far is that because of the 4 round trip time which is attached to the cost, then people tend not to use it.
Yeah, but it also doesn't actually provide guarantees for the client.
It's supposed to. They may have a bug or depends, but I'm talking even about the basic features like maps and other things that people tend not to use Cassandra, or just add multiple columns. The more columns you add with Cassandra and also with Scylla, your performance will be affected. That's true, but with Scylla you can still add plenty of columns and you'll perform very good. And with Cassandra, then you stop. Okay, another issue is like things like maintenance and running repairs and compaction. Because all of these tasks are relatively are easy for Scylla to do, then practically you don't suffer and you do not spend time maintaining your cluster with Scylla. So the same cluster, you won't see, you won't even observe the maintenance actions with Scylla, and it just leaves you to your other very important things. Oh, one nice thing is the Scylla performance is better than Redis, so you do not need to put a cache in front of the database. Like, why? And there's less object to manage, less cluster to manage, and if you move the cost of the RAM that you reserve for Redis or Memcache, and you move it into Scylla, then it will even perform better. So, about the technology, the Scylla implementation within the node is quite different. So first, I mentioned C++. So Java is a great language. We even in our past wrote an operating system dedicated for Java and JVMs. So it's not that we have a problem with Java, but not with a database. It's totally ridiculous to implement something which needs to do a high speed and handle large memory with Java. The heap is a problem. The Cassandra project tries to deal with that and constantly move objects from the heap outside, but they just suffer, and it's the worst of all worlds because they still suffer from the heap and the garbage collection and configuration. But if you move objects off heap, then now there's complexity for the Cassandra programmers that they need to manage the object and pointers and all of that. So the right implementation language for this project is C++. Beyond that, we took an idea of sharding. Everybody do sharding. We also do sharding on a cluster level to nodes. But within the nodes, we do sharding on a per core basis. So it's totally transformed from the developer or the DevOps person. But practically, each core is an independent unit that has its own resources, CPU, memory, even virtual NICs card in the future, SSD access. So there are no locks, no threads, and zero copy. And that's most of the benefits that we got is from this design. So if I put that into a diagram, then this is Cassandra design, a standard Linux application, multi-threaded, and it's because of the multi-threading nature and the multi-core era that's the problem, because Cassandra has a lot of threads, sometimes 100 of threads, and constantly needs to manage thread pool. But the problem is there is a JVM here that's another big infrastructure underneath, and there's another infrastructure here, the Linux kernel, which is generally fantastic, but the kernel doesn't have the view of the database about all of the objects. So if a network packet reaches one core, maybe the thread that handles this packet resides on another core. So the CPU cache isn't effective. The caches need to be invalidated, and again, data needs to be sent to the remote cache by the processor, but it's all tenfold times costlier than what we do with our own shard per core thing, where everything reaches the target core. Same thing happens with memory. If you have two socket machine, then accessing a memory on a remote socket is twice as expensive. We do not suffer from it. And scheduling, that's another problem. Scheduling here is generic, and we control our own scheduling. With us, you just have multiple instances with the number of cores, and we scale linearly with the number of cores. It's really nice to see. So each shard has a CPU of its own. It's one thread per core. It has memory of its own, and even a virtual NIC access of its own. The performance I showed you before is using the standard Linux networking, but we have a new development coming up, and that utilizes our own TCP stack that bypasses the Linux kernel using a package from Intel called DPDK. It's Data Plane Development Kit, and it's practically a user space driver package, which we implemented TCP IP on. The reason we implement TCP IP on, it's not because we love to implement TCP IP, which we do, but when we used the Scylla engine, which its name is C-Star, We use the basic implementation of Memcache to measure the engine. We saw that 90% of the CPU goes to the kernel for TCP/IP processing, because Memcache basically is really dumb application, just caches key and value. So most of the work lies in the kernel's TCP/IP implementation, which suffers from all of these reasons. So our own TCP/IP with the same principle of shards per core boosted the performance.
Can you go one back for a moment? Do you have an estimate which of those points have more impact on performance?
No.
How much the single performance is better on single CPU core?
Even on single one, I believe that it's something between 50,000 to 80,000 CQL operations on a single node. And
Single core.
even more?
Single core.
Single core. So the more core you add, and it really goes linear. We do not have a lot of time, so basically, yeah.
How is your memory consumption works? Like if you have like let's say with 64 gig memory, with regular Cassandra and Java, you can't utilize it all. So how does it work with your?
So the rule of thumb with Scylla is to take all of the resources we find. So practically, if you do not hand us any special command line parameter, we'll take it all. We'll take all of the CPUs. Right now, it's not necessarily something to brag about, but it is kind of cool, and we'll improve it in time. If we run on, let's say, 10 core machines, then you'll see in Linux top, you're going to see 1,000% CPU processing, 0 idle time. You'll see 10 cores hammering down, even if it's idle and you do not send CQL command to it. The reason is that we do, it's called poll mode. We do not use interrupts, and we just poll mode constantly, and we wait for data to come to this processor. We're going to relax it, so when you do nothing, then it will fall back from poll mode to a lower frequency and just increase dynamically. And that's another rule of the thumb that we have. Try not to throw a lot of knobs on the user and try to automate it all. So basically, we'll take all of your CPUs. It is possible to just specify how many cores, and this way you can specify, let's say, I'd like just 4 cores, and all the rest I'll dedicate to Solar or Spark on the same machine. Works like a charm. And about memory, again, it's configurable. You can specify an amount of memory to give to Scylla, and it will divide it evenly through its shards. But basically, we'll take all of the memory minus 5% that we leave for the OS. So we also use huge pages most of the time. And that's another thing which is important for performance. But basically, we'll take it all and we handle it all. And it's good because that's the trend. And AWS presented that they're going to have 2 terabyte RAM machine, like crazy. But how much memory can you exploit with Java? Not that much. And even today, certainly you can go to 2 terabytes. And for us, it's classic. We have our own scheduler, which is really, really cool. It's reactive programming, but I won't go into that. But we schedule a tiny object within it. Instead of scheduling threads, there's 1 thread per core, and within this, we handle our own scheduling. Still, from the Linux perspective, it's just standard application. But we don't do any fancy trick. We do not even install any kernel model. So there's no need to be intimidated. It works using Docker or better on bare metal or virtual machines. Debian and CentOS are supported. I do have slides about memory, so we divide memory evenly within the cores and the shards, and each shard has its own memory, which we manage, and unlike the situation with Cassandra, which relies on the JVM, and it relies on the memory subsystem in the kernel. Now, if I'll go more specifically, we have a unified cache. We do not use the Linux page cache as a application which calls themselves database somewhere. Oracle, for example, they take the same approach, and that's the right approach. The problem when you have a Linux page cache is there are multiple problems. First, you need to copy the data. It's not zero copy, so you already incur a pretty large overhead. And Cassandra has additional caches here, and it's tricky to configure the amount of cache for the key space and the row cache if you even aware of that, and how much memory to give to the Cassandra, and you do need to reserve memory for the page cache. It's complexity nightmare from the perspective of the administrator, and eventually it doesn't perform good. So we save the tuning, we provide better performance. If I'll go, one example is for a cyclic row. Let's say you have a row that only need to store there 100 bytes or 1 kilobyte. If this row is cached by the Linux page cache, then you waste full 4K cache for it. And later on, it's being cached over there, so the waste is even more. We cache just the object itself. And another thing, really cool thing is page fault. When the data isn't in our cache, we know it because it's our data structure, and we schedule a synchronous call for the disk to bring the data, and we reschedule the task to do something else that we choose. On the other hand, what happens in an application that uses the Linux page cache is, boom, a page fault, and the application doesn't know anything about it. So the thread ceases to run until the data is brought from the disk, and that's really slow. And now you need to have a context switch for another thread, and maybe this operation was super important, and you wanted it to be as low latency as possible. That's pretty painful with Cassandra. That's an example for our C++ code, which doesn't look at all like C++. It's a combination of Avi's sick mind. Usis over here is our CTO and main coder, and it's reactive programming together with the safety of a strong typing. Really cool thing. And it's, by the way, I didn't mention, sometimes we take it for granted, it's all open source. So it's 100% open source today. Go ahead to GitHub, it's all there. You can download it, the RPM, there is the source code.
What's the
Sorry?
what license model?
AGPL for Scylla. We have, the engine is Apache.
So you're talking about open source. I think one of the reasons that products like Cassandra and Spark are so popular is because they use high-level languages, Java or Spark. The community develops it, grows every day. Now, aren't you worried that with your solution, we won't be able to grow as fast as those products?
We will, because if you look at the community that really developed the core support for Cassandra and the server side, there aren't that many programmers. It's really tricky.
98% done by data.
Yeah.
And so, and the rest, it's not like it's random, enthusiastic that believe in Cassandra and decided to work on it. I met several of them. Many are employed by large companies like Apple or eBay or RSA, and just employed on the project. So once there is enough interest, then the community will come. And we do not expect that to get a lot of contribution to the core project, because it's really damn hard. It's even hard in Cassandra to do something significant other than small bugs. Of course, we love to see contributions, and the C-star engine, which is in the heart of the system, is really good to do handful of, or more than handful, other things. You can implement some other protocols with it. It's super fast, and that's the single TCP stack on top of DPDK, so it's really rocks. And some developers and companies are considering how to extend it.
I was about to ask you kind of the laugh of are you going to open source it, but if that's open source, what's your business model?
Open source isn't necessarily a business model, it's sort of a go-to-market strategy, and it's something that we love. For the past 10 years, we've been involved with open source projects, and our team is totally distributed. We're 21 people, distributed into 10 countries, and so we're working on open source by nature. There are multiple examples of how organization manage to monetize and productize open source products, from Red Hat to Mongo to Cassandra, each with its own twist. But basically, we're going to give support, and there's going to be a yearly subscription where you get the support, you get documentation, training, etc.
Speaking of code, how many lines of code Scylla proper without C-star? Just Scylla.
You know,
No idea.
Order of magnitude, like 10K, 100K, million?
it's not 100K, probably around 20K, but I can be wrong by a factor of 2.
Is it being used in production anywhere at this point?
No, we do not recommend production today. It's in beta for the past two months, and people are using it and testing it. We'll be in production ready in January, 2 months time from now. The main thing we do is to try to test it really, really hard, run Jepsen or against it, run and stress the clustering, the multi-data center feature that we have. We support node tools, so today if you're going to download it immediately, then you may run into some tiny quirks of node tool commands that may not be implemented fully. For example, the Dev Center and Ops Center connect and retrieve data, but not all of it. So that's what we do for the next 2 months. But we expect it to be really, really stable in 2 months' time and be production ready. And of course, if you do download it and use it, please report on any issue you may find, whether it's a problem or even good thing that you did manage to run it. It's supposed to be trivial because except for the RPMs and Debian files, there is an AMI and a cluster, how it's called, a reflector. So forming a cluster on AWS is super trivial.
Gap analysis between Cassandra and the Scylla, you said about counters and other things. So what was the gap analysis? Do you prepared statements? Do you
We have a prepared statement, and we promote prepared statement, and we were even puzzled why a Spark connector doesn't have a prepared statement. It's much better, of course, but we have prepared and non-prepared and locked and some other cool things. We want to have also authentication and encryption.
So if I want to know today what's the gap analysis, to know what features I have, what feature I lose.
There is a status page on our website.
Okay.
Very simple to reach it, and there are multiple tables that Saf, our product manager here, handles, and there are GitHub issues to add things. So the gap is we have everything but counters, secondary indexes, user-defined functions, and lightweight transactions.
Okay, and the last question is, if I want to test it, and I have my own data, and you said I can use my own files. So, do you have a guide there that tells me you install it and you map to the files, or I need to?
So yes, we do, but to be honest, our documentation is not perfect yet. So if you do missing anything, drop me an email or open a GitHub issue and get it to you as soon as possible.
It's supposed to be simple, and you just, there is a YAML file, you can adopt your YAML file, and to our, basically just rename it Scylla.yaml from Cassandra, and it's supposed to work. Again, it's still beta, and it's open source, but it's supposed to be super easy.
Why did you choose Cassandra to re-implement and not another database? Or?
It's a good question. And we're right now in the process, I can say that we're pretty happy with our choice. So, and the more I learn about databases and the ecosystem, I see that I'm even happier with the choice that we've made. The reason we chose Cassandra is initially, and it's sort of our luck or our destiny, because initially we developed an operating system and we target Cassandra as a workload to run on top of it. And we discovered that even though we come up with a new kernel for the operating system, Cassandra doesn't get to utilize all of the resources, just utilizes half of the CPUs, and the disk isn't utilized. Before, on the previous sessions, there was a discussion where you need to place the commit log or the data on different partitions. With Cassandra, it's slow, so sometimes you don't see these differences. There are differences in the disk split, but Cassandra can't utilize them. So we saw that initially that was our introduction to the Cassandra performance issues. Then we knew, we designed these really cool sharding and engine mechanisms, and in parallel we considered which problem should we attack, whether we should stay and stick with Cassandra or should we do something else. And we could have done Mongo, for instance, but the problem with Mongo is that it's schemaless, and by nature it's supposed to be less effective because there's still a magnitude of the unstructured data there. So it may be harder to optimize. And it's also written in the right language, C++. I'm definitely sure that if we need to re-implement Mongo, then we'll do a better job.
Your
But
next
the
target is
difference here we do 10x, and with Mongo we may going to do 2x, 4x, any number will be good, but we wanted a larger gap. We also considered to rewrite HDFS, which, if you ask me, suck. But since MapR already done it, then again, the game would be again versus MapR. With Cassandra, it was just with Cassandra, and Cassandra runs with their hand behind their back. Now, up until now, I told many bad things about Cassandra, but there are plenty of good things. That's the reason that all of you are here, to hear about Cassandra. So, and probably I do not need to preach it to you guys, but Cassandra has a lot of good things, especially if you need a database which is highly available and can survive in data center loss, then that's practically points just to Cassandra. And the entire industry knows that, and that's why Cassandra is successful. And you see it in natural places like e-commerce and IoT, but you can see it in unnatural things like cyber, and even telcos use Cassandra because of the multi-data center properties. So it's good, and we hope to marry the best of all worlds.
Has there been a reaction from DataStax?
I think one of the reactions, if you followed the meetup journey here, it was supposed to be 3 great presentations by 3 great speakers, and you ended up with 2 speakers. And thanks for the other 2 speakers. Then we added this parallel setup. So DataStax naturally do not love us that much. we do hope to grow the ecosystem, and all of the vendors should eventually benefit from it, because there's a Gartner research that says that 53% of those who try Cassandra ditch it due to performance. So we hope to at least get a hold of those 53% and also a large percentage from the Cassandra community, because basically there's no real reason. Once you validate us and you feel comfortable with it, there's no even one single reason why to stick to Cassandra.
I just want to add that I'm kind of angry with DataStax for moderating the content of this meetup, because it's supposed to be a community meetup. So I've opened a new meetup group for Cassandra users in Israel that's not affiliated with any corporation. Thank you.
Where are your target audience exactly? Because we have existing users of Cassandra, we've been using it for 4 years in production, and we're not heavy on Cassandra users. However, the biggest obstacle for us for adoption would be how do you prove that what you do actually works outside of performance? That you don't have any double issues, that you don't have memory, so all the things like that. Those are the biggest things for us, because we have live customers. If we move to different databases, there's one data corruption, we lose the customer. And that's to us a lot more important than,
certainly that's something to be concerned about, both for you as a user and also for us as a vendor. For us, we will be out of business if we won't be stable enough. So that's why when I'm asked, can I use it in production today? I say upfront, don't use it in production today. Even if you test it and everything works, still wait a bit and do conduct your tests. And we do add these mechanisms of migration out and like flexible thing that you basically we clone in real life all of the traffic that Cassandra cluster receives and copy it to a parallel Scylla cluster, and you have the benefit to test it without any risk. And this proxy is transparent and it's not part of Scylla, so it's supposed to be really, really easy. Now we run the Cassandra D-test, we run the Cassandra unit test. The very same tests that were developed for Cassandra. We're compatible, so it just runs. We run Jepson right now, and we'll continue to develop more tools to make sure that nothing bad will happen.
So you run full suite of Cassandra unit testing?
Yeah.
All that pass?
And nightly deals and the full month.
Can you describe these point subscriptions that you're going to be putting in place and approximately the pricing?
Let's put it out after the session, because let's stick to a technical one, but basically it's supposed to be similar to what DataStax charge. If you go to our website, you will see a lot of the graphs that I presented before about the cluster setup, and it's super cool. Initially, there's 100% write workloads, and after 10 minutes, we do a population for 100% read workloads, and afterwards the next one. And the tiny hiccups here are the compaction. And the nice thing is, when it ends, then nothing happens afterwards, because we compact in real life. It always gets compacted. Now, really funky thing that we observed when we run the same workload on Cassandra is that we saw that the number of total operations in time over a period of 50 minutes improved slowly in time. And it was really weird, because it can't be the JIT, because JIT takes several seconds and that's it. But that took a lot of time. And eventually it was pending compaction that kept on happening in the background from the previous workloads. And we did keep it fair, but we want to realize what's all of the numbers that we publish are the topmost number, not the initial number. But this is the kind of thing that you do suffer with Cassandra, and with Scylla, then you just don't see it, because the gap here are a couple of, the gap here is around 100,000. In Scylla, the gap is smaller, and practically it's just lost in noise. So it's really nice side effect, but managing it's just painless. So we discussed that. We do have Spark and Thrift. We will come around January, February. Do you have a question?
Can you compare high level your network utilization compared to Cassandra?
I can. I can show you right after because we have the detailed blog about the Cassandra performance, and there is a in and out network packets and also the disk activity, and we can compare that with Cassandra. If I recall correctly, it's supposed to be around the 200 megabytes figure. We used 10 gigabit networking. It's 3 physical servers and software. I think now we're running out of time, but basically we look forward to do things like Scylla is an infrastructure beyond the database side, even move things into the client side. And since we implemented with this engine a really fast web server that can do 7 million IOPS, then you can marry the web server and a Cassandra client and enjoy end-to-end performance on all of your infrastructure, not just the database. There are more things coming up, but it will take time. For the next year, we'll be focused to improve the core database, maybe through multi-tenancy, maybe through some other things.
Do you plan on changing the client as well? Like, do you think there's optimizations to be made on that side?
Yes, but not in the really near term. In the near term, the same clients with all of the multiple languages that are supported will continue to work. Eventually, when we'll come up with new operations, then we'll have to change them. We even have a desire that if we'll enhance the secret language, then we'll contribute the changes to Cassandra, and so the two projects will enjoy from it. We'll see how it will work in practice, but that's our desire. And I could say when we developed the KVM hypervisor, we contributed code to Linux and even to Zen hypervisors, so it shouldn't be a problem. And thank you very much.